Okay, so this is where we left off. Welcome back from the break where we looked at the rules of probability. All right. And we use the sample space from casting a die to look at these rules in detail, right? Now, for all the examples in this course, especially under probabilities, the events we are going to consider mutually exclusive events. This means that the events can't happen at the same time. Now, the coin can either be heads or tails, never both, right? So that is what we're going to consider. Now, the customers can wait 4 or 5 minutes, not both. Is that okay? So we look at mutually exclusive events, and that's the explanation for mutually exclusive events. All right. Now, let's look at probability statements. And here we are going to look at how we can use the and, okay, the not, and the or statements. Now, we want to consider that using the data on police officers and fill in the missing quantities. Now, we have categories, so promoted in the last year, not promoted in the last year, and the total. Is that okay? So we have the row total, and then we have the column total. Is that okay? So let's do these totals. Sounds good? So if you put this and that together, we get that. This and that together gives you that. Now this and that together gives you that. Okay. This plus that gives you that. And then the totals, that gives you that. And then that also gives you that. You know how this is formed. Okay. This is easy. All right. Now, you want to circle each group of numbers that sum to 200. Are you able to circle each group of numbers that sum to 200? Try that. Okay. So you realize that you're going to have these circles, 3 circles, and these sum up to 200. Now, what is the probability a police officer selected at random is female? Female. The police officer selected at random is female. Okay, so number of items of interest. So the total female police officers is what? 80. And then over the total, both male and female will give you 40%. So pay attention closely, okay? And Gucci, all right, let's go. Now, what's the probability a police officer selected at random is male? Okay, yeah, you guessed right. So that will be what? 120 over 200, so 60%. What's the probability a police officer selected at random was promoted in the last year? So promoted. So you look at the total for promoted, right? Promoted in the last year over the total. What's the probability a police officer was not promoted? So we know promoted, right? So not promoted is what? Wouldn't that be just 75%? So when you know not promoted, okay, so you could have just done that. So if you're using percentage, stick to a percentage. If you're using the decimal, stick to that. Either way, you get the same answer. Okay, so we call that a complementary statement. So not promoted, the total over 200. And you could have also done just 1 minus that, and that'll give you the answer. So here, we look at the rule for not. So look at this. What is the rule for using not when calculating probabilities? So subtract the probability that it does occur from what? 1. So we have dealt with 1 case. We now know how to use not in probabilities. Are we good? All right. Thank you. Let's go. Now, we want to look at how to use and, right? Find the probability of selecting at random an officer who is a woman and was promoted. And was promoted. That means what? Both criteria must be met. So find the probability of selecting at random an officer who is woman and was promoted. What do you think? Woman and was promoted. So this is it, right? 20 out of 200. So you look at both. Is that okay? Nice. Find the probability of selecting at random an officer who is a man who was promoted in the last year. A man and promoted. So man and promoted. Do you see that? Now, what is the rule for using the and when calculating probabilities? All right, take the value at the intersection of the criteria and divide by the total. Is that okay? So note this rule closely. Note the rule closely. Okay, that will help you to solve problems. So depending on the statement, okay? So look out for these when you are solving probability statements, okay? Now we look at the or scenario, the or case. What is the probability of randomly selecting a police officer who is female or was promoted? So or means either criteria is met. We have circled these values in the table. So if you can see what has been circled, that is it. Be careful not to count 20 officers who are female and promoted twice. So we are going to do that by subtracting. So to do that, so we are looking at selecting a police officer who is female or was promoted. Okay, so female or was promoted. Okay, so what did we do? We will put these totals together and then we subtract this 20. And the idea is to not to count 20 officers who are female and promoted twice, because don't forget that this 20 fits into this total. So we have to take that out and then we divide by the total. Is that okay? So that is how you find that. We will do a number of examples. Now, what's the probability of randomly choosing an officer who is male or not promoted? So we're talking about male or not promoted. So you circle male, right? And not promoted. Okay. So what do? You put these totals together and subtract the intersection and divide by the whole. Is that okay? Let me rub what I did and you subtract that. So that's how you deal with the or case. Okay, so this is it. Add up the values in the union of the criteria, being careful not to count the values in the intersection twice and divide by the total. Is that okay? Think about it. Sounds good? All right, so that is how you deal with that scenario. Now, we look at conditional probabilities. Conditional probabilities. Suppose we already know a condition before we look for a portion of interest. Consider a condition a change in the denominator. So anytime you're talking about conditional probabilities, consider a change in the denominator. Is that okay? So this will show you conditional probability. So if you see if or given, this should give you an indication of what? Conditional probability. So these two words should tell you that you are dealing with conditional probabilities. Is that okay? If or given should tell you that you're dealing with conditional probability. Is that okay? Nice. So here, that is it. So if a police officer, so if should give you an indication that you're talking about conditional probability. What is the probability he was promoted? So if, so that over the row total. Okay, so if you see if, stick to the row or stick to the column, depending on what you're doing. So divide by the column or the row total. If a police officer is a woman, what is the probability she was promoted in the last year? Officer, female, and was promoted, if. All right. Is that okay? So you divide by the row total. If an officer was promoted in the last year, what is the probability the officer was a woman? All right. So that is what? 20 over 50. Is that okay? Nice. So if a police officer was promoted in the last year, what was the probability? What is the probability the officer was a man? Promoted and man. If. So anytime you see if, okay, you use the column or the row total, depending on what is being asked. So we are looking at if police officer was promoted. So if, so we have to use that total. Man. Okay. And we do the same thing, but here, these are two same statements, just that the wordings are different. Now, this is how you organize, you recognize conditional probabilities or how to calculate them, all right? So watch out for if. If you see if, okay, or given, you are looking at conditional probabilities. Is that okay? Now let's go further and see some more examples. Okay, nice. So here we have this table that has eye color, right? That talks about eye color. So we are going to look more on the conditional probability. So blue eyes, brown eyes, green eyes, all right? So right here, find the probability of choosing a female given a student with brown eyes. Okay, so that has been done. Now complete the ratio to find the probability of choosing a student with green eyes. If the student is female, if the student is male, sorry, if male. So if male, so you have to use the total for female. Is that okay? Now we're talking about green eyes. Is that right? So that's how you interpret that probability. Now, find the probability of choosing a female with blue eyes. Okay, there's no implied condition here, right? The statement is big. We are assuming that choosing means choosing a student at random from all students. Is that okay? So we have to use here, we have to use the whole total. Is that right? Now, given that a student has blue eyes, given that a student has blue eyes, is that okay? So here, you have to use the blue eyes total given because of this word. That should tell you that you are dealing with what? Conditional statement. Is that right? Good. So here, we are actually looking at how you can get the meaning of a conditional statement or probability out of a research. Okay, so we look at the various interpretations. Okay, so according to the 2006 European study, the risk of developing lung cancer for a man who never smoked is 0.2%, and the risk for a current male smoker is 15.9%, which is almost 80 times higher. Now, we want to restate these statements. What are the conditions of each group of men? And these are the conditions. If you never smoke, the probability you will get lung cancer is 0.2%. If you are a smoker, the probability you will get lung cancer is 15.9%. Okay. Now, how did the researchers find each probability? What values were used in the ratio? Okay, used to find the percentages. Those with lung cancer and never smoked to those who never smoked. Is that okay? So this is more of an application question to get you to get to know whether you really understand probability statement. Is that okay? Nice. All right. So right here, we have this large table talking about, this is from in 2017, the Bureau of Labor Statistics collected the age of employees by occupational category. All values represent numbers in thousands. All right, so we have employees, their age categories. Now we are going to analyze the data set using probability statements, right? So use a table to address the following. Express all probabilities as percentages rounded to the nearest tenth of a percent. Okay, now if an employee is selected at random, find the probability that the employee has a service occupation. Are you able to locate a service occupation on the table? A service occupation. So it did not talk about any age category. So we are talking about the total for service over the total of employees, right? You get that? Nice. Now, what proportion of employees are aged 16 to 19 and possess a management professional occupation? Okay, so it gives the age category, right, over the total, and that gives you the proportion. And here, it says that what is the probability of randomly selected an employee under the age of 35? So you put all these together and divide by the total. And that gives you that. Is that okay? Nice. And here we are dealing with the or statement. Calculate the probability of selecting a sales and office occupation or someone aged 45 to 54. Okay, so because we are dealing with the or scenario, we are going to put these totals together and take away this guy and divide by the total. Okay, so that is how you deal with the or case. We just looked at how to do that. Do you remember that? So note how you deal with the or scenario, the or scenario. And here, again, we are dealing with this same guy. So we have to put these totals together. Okay, subtract that and divide by that. And that is how you deal with the or scenario. Okay, so note. Sounds good? All right. And here, you just divide, right? So no conditional statement is implied here. So you have to do both, okay? And then you look for the one, okay, with the lowest probability. All right. So basically, that is how, these are the analysis we run under these tables. So note how to deal with the and scenario or the and case, the or, okay? And then the if or given. And finally, there's one more, and then the not case, right? So note how you handle these statements, okay? Now here, we look at empirical probabilities are based on experimental outcomes rather than theoretical outcomes. So we're looking at practical cases. So if we were, so here, this is more of an empirical, right? So we're going to look at these candies. We select the red, look at the yellow, okay? And you like these guys, right? MMMs, but I say it in a very funny way, MMMs. That sounds funny, right? So we're going to run these, all right. Now, without looking that, you want to do a tally, and then you try to look at the totals, and then you look at the various probabilities. And that is empirical, more practical, right? So here we want to look at this example. So during the past year in the maternity ward of a hospital in a large city, 1,254 males were born and 1,462 were born. What's the probability that the next baby born in the hospital will be a boy? So the number of boys over the total boys and girls, right? Now, what is the probability that it will be a girl? So number of girls over the total, right? And that is how you find these probabilities. Now, Ivy Tech's latest diversity report stated that the Central Indiana Ivy Tech had about 13,600 students that identified themselves as Caucasians and about 9,000 students that identify themselves as minority. Now, what is the probability a student chosen at random from this group was a minority? And that is 39.8%. Okay. All right. So here we do same stuff. So if you go by the rules of probability, questions or problems under probability should be very easy, right? So if you look at this chart, how many students are there? So you just put the numbers on these together, and that gives you the number of the enrollment. Now, if you pick at random what the division they were most likely, so that should be the other, right? Because the other has the tallest bar, okay? So that is that. And then if you select a student, what's the likelihood they were from the university and transfer division, right? So you look at the university and transfer division over the total, and that gives you the probability. Not from, so the not case, so you just, because you know this, you take that from 100, and that gives you the not from the university and transfer division. Sounds good? All right, nice. So that is all that we have to look at under the first part, like I told you. All right, so this is the second video. Now we are going to do, I'm going to do a third video, and that will cover false positives and false negatives. Is that okay? So far we have dealt with all the rules of probability. We know how to deal with the not, the and the or, and the conditional statements. All right, conditional is if or given, right? And we've looked at a number of examples, and we looked at empirical probabilities. All right, so I'll see you soon for us to discuss false positives and false negatives, all under probability. All right, so thank you very much for your time, and see you soon. Bye.